practice 3, midterm practice 3 of math 100. So the first question is find the domain of continuity of the function f of x. This is question number 1, a. F of x is x over 2 sine x minus 1. So you need to know that anything about domain or anything about continuity in this case is you find the discontinuity and exclude them. So in this case we want to find anything that will make the denominator 0. If you see any square roots, then you have to make sure that you exclude those negative in the radicand from the domain. Or in those cases where you have a square roots, it's easier to find all the possible x's that will make the radicand greater than or equal to 0. And then the third possibility of exclusion would be if you see functions like ln of something, then you know that whatever this angle is, it can only be strictly greater than 0. So that's another way to start finding out the domain of any function that involves ln, ln, because the domain of ln is it can only take positive arguments, which means that x squared minus 1 must be greater than 0. So 3 rules. Number 1 is the denominator exclude those denominator that will make the denominator 0, or in other words, the rule is denominator cannot be 0, so exclude those ones. Second one is start with anything inside the square roots, so-called the radicands, that has to be strictly greater than or equal to 0, and that would be part of the domain. Okay, not to you have to exclude the negative ones, but then you therefore start with greater than or equal to 0 to be the positive one. And the third part is therefore functions involving log, where whatever the argument to log is, it has to be greater than 0. Similarly with tangent, because you know that whatever tangent is cannot take pi by 2 or negative pi by 2, so this cannot be, therefore you need to exclude that. Pi by 2 plus or n pi, that is the what you need to remember, what to exclude when you have a tangent function, because domain tangent cannot take a pi by 2, because tangent will become infinity, or negative infinity was negative pi by 2, for example. So these are some of the rules. So in this case, we have 2 sine x minus 1 cannot be 0, so we need to exclude those ones, which means 2 sine x equals to 1, or divided by 2, so sine x equals to 1/2. According to the cast rule, there are 2 possible quadrants where x could be in that will give you positive half. One, of course, is sine 30 degrees, or pi by 6. Remember, in calculus, you cannot use degrees. So sine pi by 6 is 1/2. We also know that sine 5 pi by 6 is also 1/2, because the reference angle is pi by 6 here, or pi by 6 here, but the standard angle is 5 pi by 6 from the positive x-axis. Therefore, you have 2 answers. So x could be pi by 6, then it will give you 1/2. X also could be 5 pi by 6, that will also give you 1/2. So plus or minus 2 n pi, plus or minus 2 n pi, where n is just any integer you like, then these would be the numbers. These x's will therefore make sine x 1/2, and therefore times 1/2 minus 1 will make the whole denominator 0, and therefore these are the ones you want to exclude. So the domain of continuity therefore will be a set of x's such that x cannot be pi by 6 plus or minus 2 n pi, and x cannot be 5 pi by 6 plus or minus 2 n pi, but n can be any real any integer, but x can be any other real number otherwise, excepting these 2. So that will be one way of writing it. And question number part B, find the derivative of cosine x to the ln x. So I may have to digress a little bit to do a review. If you have a variable to a constant, okay, for example, I'll give you some variables, x squared plus 1, to a constant. Let's say I have e to the pi. Well, this is really a constant. E to the pi is really constant. No, there's no exponential function here. It's just a constant, e to the pi. 2.718 to the 3.14 is just a number. However, when you deal with this, many people will be mistaken to take a power rule on this. But really, this is just a power rule. So that means the derivative of this, the derivative of that is simply e to the pi, x squared plus 1 to the e to the pi minus 1, like so, times 2x. That's it. Okay. Do not let e to the pi to confuse you into thinking that it is an exponential rule or something like that. This is just a plain power rule because this is a variable at the base, constant as power. Well, then the second one is you have a constant to some variable, which is, for example, I may have pi squared plus 1 to x squared minus 1, for example. Now that's a constant base. Pi squared plus 1 is just a constant to the variable x squared minus 1. That you cannot use power rule, because power rule can only be applied to a variable to a constant, not constant to a variable. That you have to remember to use the exponential rule. Now the exponential rule says a to the u, the derivative of such, is copy itself times ln a, okay, a being the base constant, times u prime. Okay. Now in the past you learned e to the u, or that's e is actually a special number. It's a very special case, which is e to the u times ln e times u prime. But ln e is 1, so that's why you usually see the exponential rule written like this. But that's not as general enough as any other base, so you should remember this one instead of this one. So therefore, if I have this question, I will just say, oh, the derivative of that is simply the derivative of that is simply first copy itself down, then do the ln of the base, so ln, the base is pi squared plus 1, and the times derivative of the exponent, 2x. Done. Okay? So that is how you deal with constant to a variable. Now then, you have constant to a constant to a constant. Well, how difficult is that? Well, for example, I happen to the e squared plus 1 to the pi squared minus 1. Well, that looks all very complicated, but the whole thing is nothing but a single constant number. It has nothing to do with x. So the derivative of all that is just 0. Okay? So the derivative of that is just 0. Now the last one is a variable to a variable, which is our case here. Now that says you should take the ln of both sides first to bring down the exponents. Okay, so for example, you have that, then you do a ln y equals the var ln base. Okay, this is the base, which is a variable. And then you have product rule now, and then do a y prime over y equals the product rule on this. Okay, which is derivative of the first times second plus derivative of second times third. So that's what you do. Now, if you do this a couple hundred times, then you realize that when you have a variable to a variable, it is simply copy itself down. Okay? And then copy itself down, and then you do a ln of these, you do a derivative of these two as if they were multiplied. Except there's a ln of the base that you have to consider. So this is like a ln, okay? Consider that as a ln first. And then the product rule of this and ln that. So you could write as var ln var, which is a base, do a product on that. Okay? So if you don't remember that, then just take a ln both sides. For example, here we'll do a ln y, bring the ln x down and then ln cosine x, right? Because I'm taking along both sides. And then I take a derivative of this. Isn't that product rule? You know, but product of this and ln of the base. Okay, ln of the base. So that is x 1 over x ln cosine x plus ln x. Derivative of ln is u prime over u. So derivative of cosine, which is negative sine over u cosine itself. So this is just cosine ln cosine x over x plus ln x times negative tangent x. So you could rewrite this as ln cosine x over x minus ln x tangent x. Now all that on the left hand side is y prime over y. So y prime is now simply y times all that. Y is all that, which is copy itself, remember, or just itself. Then times the product of ln base and the exponent, which is this. So ln cosine x over x minus ln x tan x, and then leave it like that. Okay, so question number 2. Question number 2 says, show your work. A particle travels on the x-axis. Its position function is given by f of x, or f of t is 5t minus t to the 5th in meters. So what we need to know is, they say, find the total distance traveled in the first 2 seconds. Now, distance travel in the first 2 seconds. Now, if you think about the number line, where he is 0 here, and when t is 0, it is 0. But let's imagine I'm actually looking at the distance travel, like the position of the particle, and here's t-axis. If you travel up and down, or left and right, doesn't matter. I mean, this is one-dimensional movement. So when t is 0, it is at 0. But you can see that if t is 2, 5, t is 0, f is 0. But when t is 2, this is 10 minus 32. Okay, so negative 22. So when t is 2, here, his position is actually at negative 22. Okay? If you were to just subtract, if you just say the answer is 22, then you'll be mistaken, because he did not travel straight down. He actually traveled up and down, like so. So the distance travel is really from 0 to a point that he has gone forward and stopped going forward, and then from that stop point all the way to the current point. So what you need to do is find out what point he actually has stopped going forward and now start returning or going backwards. The way to find that out is where the velocity is 0. That is neither going forward nor coming backward, which means the derivative of that, which is really the velocity, which is 5 minus 5t to the 4th. Where that is 0, then that's no longer going forward, because if that's positive, when t is 0, for example, he's actually moving 5 meters per second forward. But when he is at 2, this is definitely some negative number, he's going backwards. So at what point, what time, is this velocity 0? And what that tells me, that's the point where he will return backwards. So you can see that if t is 1, 5 minus 5 times 1 is going to be 0, right? So in fact, we can actually tell that velocity will be 0 when t is 1, but to show your work, you have to factor out the 5 and then write it like this, and then divide both sides by 5 and you still get 0. And then 1 minus t squared, or 1 minus t times 1 plus t, and then 1 plus t to the square. Okay, I actually factor out twice. So 1 minus t squared times 1 plus t squared, but then factor out 1 minus t squared into 1 minus t 1 plus t equal to 0. These two can never be 0. Only 1 minus t could be 0 where t is 1. So now you know when the velocity will be 0, then where is it? To find out where it is put the 1 back to the original equation. F of 1 is 5 times 1 minus 1 to the 5th, which is 5 minus 1, which is 4. So he's actually at position 4 up here. So he actually has traveled from 0 to 4, and then from 4 down to negative 22. So the distance traveled then should be 4, which is the duration from 0 to 4, plus negative 22 minus 4. Okay, because this whole distance is negative 26. But you cannot use negative, so we use positive. That's because the distance traveled does not account for negative. So 4 plus 26, which is 30 meters. Okay, so 4 meters up, 36 meters down. Okay, so that's total distance of 4 plus 26, 30. So that's the answer. So number 3, compute the limit as x approaches negative 1 of root x squared plus 3 minus 2 over x plus 1. First step is plug in the negative 1 into here to see if you get 0 over 0. If you don't, then that will be the answer. If you do, then you have to do more work. So for example, if you put negative 1 in here, you get root 4. 2 minus 2 is 0. Negative 1 plus 1 is 0, so 0 over 0. That tells you that x minus whatever they want you to approach, negative 1, equal to 0 is the culprit. Because x minus negative 1, whatever the limit they want you to go, is actually x plus 1. X plus 1 is really what causes the whole thing to be 0 over 0. And you can see that the bottom is already showing it to you. So your job then becomes getting x plus 1 out of the top. Well, anytime you see a square root, it should remind you to use conjugates. So you multiply top and bottom by the conjugate. So I'm going to say dot 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 plus 2, dot dot dot, remember dot 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 is just this part, plus 2. At the top is guaranteed to give you a difference of squares. If you FOIL them out, you have root times root, you have no root anymore, so x squared plus 3. And then this times positive will be positive 2 root that. Negative 2 times that will be negative 2 root that, don't they cancel? And then you have negative 2 times negative 2, positive 2, it becomes negative 4. That is what we mean by difference of squares. Okay, because the formula is a minus b times, or a plus b times a minus b is a squared minus b squared. Okay, so and at the bottom is, let me just leave it as that, square root dot 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 plus 2 in brackets. There's still a limit as x approaches negative 1. But now you can see that you have x squared plus 3 minus 4 is really minus 1. And x squared minus 1 is really x minus 1 times x plus 1. And here's your x plus 1 culprit that we mentioned. So these two cancel, and after you cancel them, whatever left over, you can plug in the negative 1 into it, and hopefully it won't get you another 0 over 0. So if you put negative 1 for x in here, you get negative 1 minus 1 over, remember that's gone, but you still have root of this, which is this guy. So root of negative 1 squared is positive 1, but not minus 2, okay? It's only this part, plus 2. So you have negative 2 on top, you have root 4, which is 2, plus 2, which is 4, minus 2 over 4, so the answer should be negative 1/2. Okay, let's try number C. They say compute the limit as x goes to negative or positive infinity of root x to the 4th plus 2x plus 1 minus root 3x to the 4th plus x squared plus 2, all divided by 2x cubed plus 5x plus 1. Okay, now we are tempted to use conjugates, but the thing is that we cannot really plug in this and figure out whether we get 0 over 0. Even though this is infinity minus infinity, but that does not necessarily mean 0. And this at the bottom will be infinity, so that doesn't really conclude anything. Now, you may want to use conjugates, or tempted to use conjugates, but as I said, it does not give you 0 over 0, so conjugate may not help you. So the other thing is, you notice that all these lower degree terms you can basically forget them. In other words, here, essentially, when x goes to be so large like infinity, the 2x plus 1 and x squared plus 2 compared to x to the 4th, 5x plus 1 compared to x cubed are all negligible. So effectively, you have root x to the 4th minus root 3x to the 4th all over 2x cubed. That's what you effectively have. So in your mind, you need to do this one first, but root x to the 4th is really x squared minus, this is root 3 and then x squared, because this you can split that into root 3 times root x to the 4th. Okay, and then you have 2x cubed like this. Okay, so effectively, you can do it this way. So did I copy wrong? No, this is not cubed, this is squared. Okay, that makes sense. Because this is squared, that means we then can cancel the x squared. Then you really have just this as the answer. Okay, so that is what you should to think, to work towards. If you actually had what I had before, that is cubed here, then actually the bottom will have one more degree than the top. And when x goes to infinity, top will become a fixed number, but the bottom will be infinity. In that case, that would have been 0. But in this case, okay, well, I actually copied wrong, so that was x squared. So x squared and this x squared factor all cancel with x squared, so you have 1 minus root 3 over 2. Okay, even though I say cancel, it does not mean disappear here. It's x divided by x squared, you have 1 divided by x squared is 1, divided by x squared is 1, so 1 minus root 3 over 2. So that's what you should work towards. To show your work, all you need to do is factor out what I just said. Like in this case, I'll factor out root 4, sorry, x to the 4th, like that, and then leaving you with 1 plus 2x over x to the 4th plus 1 over x to the 4th, okay? Minus, in this case, I'll factor out root x to the 4th again, that will leave you 3 plus x squared over x to the fourth plus 2 over x to the fourth, all divided by, well, I don't need to do anything on the bottom. Now then, this simplifies to x squared, that simplifies to x squared, and these two can be factored out, or if you like, divide top and bottom by x squared, so that just becomes 1, that becomes 1, that becomes 1, that you have to divide by x squared, divided by x squared. So without actually rewriting a whole bunch of your work and waste your time, you just cross out as is, and then you show that limit as x approaches infinity. All you have here is 0, or there's a 1, these are all 0, these are all 0, so all you have left is 1, root 1, which is 1, minus root 3, still there, divided by 2. Now these are 0, but this is not 0, this is just 2, okay? So that's your answer. Okay, so the next one is number 3, find the derivative of the function x over root x plus 1 by definition. By definition means that you could do it using limit h approaches 0, f of x plus h minus f of x all over h. That's one way. The other way is limit x approaches a, f of x minus f of a over x minus a. But the problem is that using the second way, your answer is going to end in some sort of ace, okay? But the question is in terms of x's. So when you give your answer in terms of x's, you have to replace all the a's that you see here as x. So that you answer, let's say if this was a squared plus 1, then your answer would be x squared plus 1 because they never gave you any a's. Whereas if you did it this way, you don't have that problem. And notice that in the answer, they already gave you this method, and then at the bottom, they show you the answer already in terms of a, but then they have to replace the a's by x's as the final answer. So you can refer to that for this version of solution. So I'm going to give you this version of solution just for comparison. So f prime of x then is equal to limit as h approaches 0. This is by definition. F of x plus h means replace all the x's in here by x plus h. So this will be x plus h over root x plus h plus 1, and then minus f of x, which is itself, all divided by h. Now, if you see a fraction within a fraction, then what you can do, you can use common denominator, which means you kind of cross multiply and then leave the two denominator at the bottom. Now, you like a over b minus c over d over f is same as ad minus bc all over f b d. Okay. Now, if you don't believe me, just work it out on some simple fraction yourself, then you should prove to yourself that this is actually the combined form of that. So I'm just going to use that here. So limit as h approaches 0 will be x plus h times root x plus 1 minus x times root x plus h plus 1. Okay, that's this part. Divided by all three denominators, but multiply together. So this is how you combine mixed fraction like that into a single fraction. Then you see that you have a root on the top, and you know that h approaches 0 means h is the culprit that you need to factor out from the top. Once you factor out and cancel the h, then you can plug in 0 again for h. So here I need to multiply the conjugate on the top, but you know that conjugate means if you have this, you multiply a plus b on top and bottom, but the top is going to be a squared minus b squared, and that is the whole idea of getting rid of square root is by multiplying the conjugate you end up with squares, which will cancel the square roots. Now, just a side note, if you see cube root minus cube root, okay, that you need to get rid of the cube root, then you have to remember the formula of a cube minus b cube is really a minus b times a squared plus ab plus b squared, which means if you see this minus that eventually you want to cube it to get rid of the cube root, you need to multiply the cube minus the cube by not the conjugate, but by this, which is the square of the first part, plus this part times the second part. Let me call this u and v, okay? That'll be like that'll be u here, v here, and then plus v squared. Now that is this part, you see? You have to multiply top and bottom by that. But the top, according to this, would then combine into a cube minus b cube, which is cube of this minus cube of that without the cube root now, so that becomes simply u minus v, you see? That is the cube root way of getting, not the conjugate, but something called this, that multiply the a minus u, or a minus b will get back to a cube minus b cube, and then all this disappear into simply u minus v. But the bottom is, a little bit complicated, like still cube root u, cube root v, plus cube root v squared, right? However, these are added, so chances are they won't give you 0 over 0. But this guy most likely will simplify out and with an h left over for you to cancel with the h in the front. Okay, anyways, that little bit sidetrack on the, if you see a cube root, okay, there's no conjugate for cube root. But you have to remember this formula of a minus b times a squared plus ab plus b squared gives you a cube minus b cube. Alright, back to here. So, I then can write square root of this minus square root of that, okay, which is x plus h all squared. But when square this, you have no more square root, right? And minus x squared times x plus h plus 1, no more square root. But then the bottom is not only that you have all this, but you also have the conjugate on the top. Plus Okay, now I need to expand and factor and cancel the top. Okay, so that becomes x squared plus 2hx plus h squared times x plus 1. I can expand that now. X cubed minus x squared h minus x squared dot dot dot. So the top, if I fold it once more, x cubed plus x squared plus 2hx squared plus 2hx plus h squared x plus h squared minus x cubed minus x squared minus x squared. So this guy better cancel with this. Now, do I see any x squared here? Yes, I do. Cancel this. So here I have minus x squared h. Now here's here is x squared minus h, and also here they all have a single h's. So that I can combine with that, which means h factored out. Okay, so I have 2x squared plus 2x minus x squared. Okay, all these h are factored out, and then plus h squared x plus h squared. You don't factor out anything. Don't worry about it because they will later on cancel. All these divided by h and blah blah blah. Okay, the blah 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 is actually everything here. So this h cancels with h, which means from now on you can now assign 0 for h's, which really means is these all disappear. Okay, because this h goes to the square already drops down to one h only, but then h goes to 0, though these all disappear. And then what you have here is 2x squared minus x squared is just one single x squared plus 2x up here, all divided by, now I was going to copy all this down, but I won't copy the h's down because h is on to 0. So here you have root x plus 1, root x plus 1, x, root x plus 1, plus x, root x plus 1. Okay, all the h is gone. Now I can simplify that even further. The top I can simplify x plus 2. The bottom, these two are identical, so that is simply x plus 1. All multiplied by these two are identical, so which is 2 x root x plus 1, 2 root x, 2 x root x plus 1. Okay, so this now then becomes okay, I see that x and x cancel here because these, remember, they are multiplied. So I have x plus 2 on top, but then I have 2. I have x plus 1 from here, and then root x plus 1. But I'm going to write it as 1/2. But these two have the same base, except exponent is here is 1 really, and 1/2, which I can combine into x plus 1 to the 3/2. So the answer is identical. Okay, except back in here you kind of don't have to copy everything down because that's going to waste your time. But you just circle it so that you know that it is about to be replaced, and then just copy it, the result as you copy them down. That will save you a lot of time. If you keep on copying, that's fine, but more copying, the more error prone you are in while you copy. Okay, because every time you copy, you might miss a sign or miss a root or miss a power or something like that. So probably best just to dot dot dot, circle the part to remember that dot 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 correspond to. Or if you like, mark it a circle and mark this one as a circle to remind you that whatever you circle here is called a circle, and the a circle is what you're replacing it with, so that later on when you do need to evaluate the h goes to 0, just drop the h's out here and then copy whatever left over as the answer. Okay, next one is show that there is a real number x such that x so that x squared minus 1 is equal to 10x. What they are really wanting to use is something called the intermediate value theorem, which means if you were to graph a function y of this, another function g of that, for example, y equal to x squared minus 1 somewhat looks like this. Okay? And g, which is tangent of x, somewhat looks like this. Now then, what they're saying is that somewhere along the x-axis that you can find a point that the two are equal, which means that y and g are the same. Well, it looks like this is the point where they meet, therefore their x coordinate or y coordinate will be the same as well as x coordinate. So that they don't care what it is, they just want you to prove that there is one. Well, one way to prove that the two curves cross each other, like in this case, even though they didn't tell you that this is a function, that's another function, but you can think of it that way. So another way of writing it is that, okay, well, if they equal to each other, isn't that the same as if I were to say subtract the two and then call a new function y which is the graph of this. But where on the graph would the y value be 0? Well, isn't that the same thing as asking where would this part cross that part? Is it the same as saying when would the whole function subtract like this is equal to 0? Because wherever the function is equal to 0, this part must equal to that part. So here the question then becomes, if you have a graph somewhere crossing the x-axis somewhere, like in this case, somewhere, we don't know. But if you're able to prove that some x that you can come up with, that y is negative, okay, here's the x-axis, y-axis, some number, I don't know, some a that you can find, where this value is negative, and some other value where this is positive. Let's say here, you find a positive value. Now, but the function is continuous between these two, a and b. Well, if this function is continuous between a and b, then somewhere must be a point that crosses the x-axis, and therefore 0. That is the intermediate value theorem. Okay, some intermediate value that is between f of a and f of b, such as 0, there must exist a number c so that f of c is 0, somewhere between a and b, right? Somewhere between f a and f b. So that's what I often refer to as a box theorem. That is, on the lower hand of the box and the upper hand of the box, if you are able to find that the function is continuous from this point to that point, then somewhere, anywhere in the box, you can find the corresponding x and y. So in this case, I want to find the point where the y value of this function is 0. Okay? But if it is 0, that means this part equals to that part. So that goes back to this question is, find the x such that this, you just need to prove that there is such an x, that this is equal to that. Now remember, here's the thing, is that it must be continuous. The function must be continuous. But we know that tangent pi is only continuous between negative pi by 2 and pi by 2. So preferably, you find such a number between the two, because tangent x is continuous between negative pi by 2 and pi by 2. Okay, so what I will do is, let me try pi by 4, negative pi by 4, and positive pi by 4 and see how lucky I am. So if I say let a equal to negative pi by 4, then f of a, which is a squared minus 1 minus tangent a, which is pi by 4 negative square minus 1 minus tangent pi by 4 negative. So this is what? Pi squared over 16 minus 1. Tangent negative is same as plus, tangent positive. So this is 1. 1 minus 1 cancel. So this is now pi squared over 16 positive. Okay, so that means that I have a box, and negative pi by 4, I have a positive this number. Therefore, I now look for a number somewhere here, I don't know what. I hope that it will be negative number, okay? So below 0. Now, if I think about it, wouldn't 0 be a great number? So for example, f of b, where b is 0, don't I get 0 squared minus 1 minus tangent 0? That's 0 minus 1 minus 0, which is negative 1. So if this was 0, this is negative 1. So I just found an a, which is negative pi by 4, whose f of a is a positive number. And I found a b, which is 0, and f of b, which is negative 1. So then you can say by intermediate value theorem, there must be a number c, which is between a and b, that is, exists a c that is in the interval of negative pi by 4 and 0. Okay? Negative pi by 4 and 0, there is such a number c, such that f of c would be 0, Why? Because 0 is greater than -1, which is f of b, and less than pi squared over 16, which is f of a. And therefore, you write by intermediate value theorem, there is at least one real number such that x squared minus 1 equal to tangent x. And that's all you have to say. Oh, that's exactly what they used. Surprising. Okay, that's exactly what they used. So on this question, one more thing is that on the test, you just need to come up with an a arbitrarily first that you plug in. Okay, the easiest one is plug in 0. Plug in 0 and you figure out what that number is. Hopefully is either positive or negative. Okay, for example, if you plug in 0, you find out this number is negative. Well, then your next job then becomes a bit harder. That is, you have to find an a or another number where this equation will give you the opposite sign. So since you plug in 0, you got a -1. That tells you that you better find another x, which this function will be positive. Then you just have to think hard enough that what number would this give you positive? Well, if you try a -1 or negative something that will be easy to evaluate, for example, -pi/4, which this one gives you -1, and then -1 plus 1 cancel and that becomes positive. Oh, that's lucky. Okay, so easy way is to find a number that will be easy to evaluate, and hopefully it turns out to be a positive number or anything opposite to the value that you plug 0 with. Since we plug 0, we got a -1, so you have to find a number to plug in here that will give you a positive number. Okay, and turns out that -pi/4 will do. So we're lucky. So you can say, therefore say there exists a number between -pi/4 and 0 such that this function or such that these two are equal to each other. Okay, so you don't really have to do all the long things I've done, just trying to explain to you how it works. So technically, just plug in 0. Okay, first write a new equation, this equal to this minus that. Okay, don't write equal to 0 though. But then you plug in 0 into here, and you find out what value that is. If that is negative, then remember that, and then you try now to find another number that you plug in here that will give you a positive number. Okay, because you already got a -1 here, so you want a positive number. And since we plug in -pi/4, turned out to be a positive number, so then you can say between -pi/4 and 0, you have such a number where this function is 0, which means these are equal to that by intermediate value theorem. The other thing you must say is by intermediate value theorem. Okay, so that is the technique. Okay, number 5, determine whether or not the function f of x, which is x e to the 1 over x, when x is negative, but when x is positive, you have x to the 3/2 if x is greater than or equal to 0. Well, differentiable means that you're able to take a derivative. Alright, so you need to know whether or not the derivative as x approaches 0, okay, because 0 is the division point, from the left and from the right happen to be equal. So that is, you now need to find differentiable, okay, has two connotations. One is that the limit of, no, we are talking about 0, right? Because that's the splitting point. So that becomes f of 0 plus h minus f of 0 all over h. Now, I did not specify left or right, so you have to prove the left is the same as the right for this function. for f of h, because his x is positive, that means I'm actually falling in this area where h is positive, right? Oh, sorry, h is negative. So h is negative from this one, positive from this one. So for this one, I need to use this function. That will be h e to the 1 over h minus f of 0, which I have to use 0 here. So which is 0 to the 3 halves over h. And if it was positive side, then I have to use this one. So that will be h to the 3 halves minus 0 to the 3 halves over h. Well, both of this is just 0 anyways. So this side, limit as h approaches 0, positive side, is h to the 3 halves over h, which is h to the 1 half, and that is just 0. Okay? However, here, you get limit h goes to 0 from the negative side. These two cancel, leaving you h to the 1 over this. But 0 to the negative side, which means something like 0, negative 0.1, negative 0.001, negative 0.0001, is always negative. But this will become e to the infinity of h approaches 0 negative, 1 over h. This actually becomes negative infinity. So e to the negative infinity, which is 1 over e to the positive infinity, which is 1 over infinity, which is 0. So actually left and right are equal. Okay, so this is what you have to prove. So left and right are both equal to 0. Therefore, f of prime, f of 0 exists, which is 0. And that appears to be the way they want it. And that's the end of the test. Now usually, okay, you also need to prove that they are continuous, but I think it should be easy to figure out because f of 0, not the derivative, f of 0 is 0 to the 3 halves, which is 0, and limit as h approaches, as x approaches 0 from a negative side, which means I have to use this one, which is 0 times e to the negative infinity, which is also e 0. So 0 times 0 is 0. And limit as x approaches 0 from the positive side is x cubed over 2, which is also 0. So f of x is also continuous at x equals to 0. But this usually is good enough. If you have time, then you can write this too. That is to prove that f is also continuous at x equal to 0.